things that I've been commenting on throughout this chapter is that when it comes to chapter 10, the individual math is not really the challenge. The challenge is when it starts getting all mixed together. Today is going to be that day where we start seeing things that look a little more similar to things we've done before, but they have a different process. Because today we're starting to introduce the relationship between arc lengths and angles that are not the central angle. Today we're talking about angles whose vertex lies on the circle and its side lengths are now, or its sides of that angle are now chords. These are known as inscribed angles. Inscribed essentially means inside of, taking up as much of the space as said shape can do. So, for an angle to take up as much space as it can, its vertex has to be on that edge as it is described. And then, as it comes out with its chords, what ends up happening is it ends up hitting and creating an arc known as the intercepted arc. Now, an intercepted arc literally just means any arc that is formed with two lines, rays, segments. So even like when we talk about central angles and their corresponding arc, we were technically talking about an intercepted arc. It just means the arc between, insert the information here of what they're talking about is it's in between. For a central angles arc, we talk about the intercepted arc of the segments of the angle. So, when it comes to inscribed angles and their intercepted arc, the angle and the arc are no longer the same. That's a central angle thing. Central angles and arcs are the exact same measure. Inscribed angles are 1/2 the measure of their intercepted arc. So, that means measure of angle ADB is equal to 1/2 the measure of the arc AB. The angle is half of the arc. Now, one of the things when it comes to this one is people tend to mix up which one goes the 1/2, so you have to be careful with that. Angle equals 1/2 arc is key. So, you're going to be asked to find various measures, knowing this information. First one says find the indicated measure. Specifically, we're looking for the measure of TV. That arc. Yes, the angle, the measure of television. That's exactly what we're looking for. Okay, so, according to the theorem, angle equals 1/2 arc. What do we know about the angle? 38 equals 1/2. What do we know about the arc?
Would it be like 76? No, it's 1/2.
Would you take 38 times 2?
We don't really know what it is. We know its name. Now, yes, some of you are absolutely correct. If I want to get the measure of TV alone, how do I get rid of a 1/2 being multiplied by something?
Divide by 1.
Divide by 1/2, or to divide by a fraction, you multiply by its reciprocal. The reciprocal of 1/2 is 2/1, aka 2. So those of you who said the measure of TV is like 76,
Yeah.
were absolutely correct. Now, many of you probably could have figured that out pretty easily without using this formula. The problem that tends to pop up with that is that when things get more complicated, people tend to mix up which one goes where. That's why you see me use the formula. Okay, measure of angle G. Angle equals 1/2 arc. Angle equals 1/2. The corresponding arc for angle G is the 90. Measure of angle G is equal to 1/2 times 90. Half times 90, or half of 90, is 45 degrees, because it is an angle. Angles and arcs are both degrees. Okay. Next one. Measure of angle EGF. Where's EGF?
In the circle.
It is inside the circle. Its vertex is which of them? G. 3-letter name. The middle letter is always that vertex. This is the angle it's talking about. Angle equals 1/2 arc. The arc that corresponds is the 58. Am I multiplying the 58 by 2 or dividing it by 2 to get the angle? Dividing by 2. Because the formula measure of the angle equals 1/2 the measure of the arc. Angle goes here, arc goes here every single time. When in doubt, use the formula. So, measure of EGF is 29 degrees. Thank you. Okay, I also want the measure of arc DE. Does that have a corresponding inscribed angle? No, there's no inscribed angle starting at E, ending at D, going to the edge of the circle anywhere. So how are we going to find it? Raised hand or stretching?
Both, yes.
How do you think we should find it?
Because there's a diameter, it's not any diameter, so you'll have to do it without a 180.
Diameters, arcs add up to 180. Good.
You have the 40, so you just multiply the 40 by 2 to get the arc. And
Yep.
you just minus the arc from the 180.
Exactly. So, there is an inscribed angle here of 40 degrees. The angle is half the arc. So, to get the arc, is that, you said I double it then?
Yeah.
Yep. So that's 80 degrees. And this arc should add up to 180. So 180 minus the 80, the measure of arc DE is 100 degrees. Okay. Just gotta make sure you're putting the angle first, the arc second in that formula. I could have used that formula to get this piece too. It would have looked like 40 degrees equals 1/2. Its corresponding arc would have been the measure of DG, which would have led to the measure of DG being that 80. So sometimes it's going to take a couple steps. Okay. Next one I'm looking for is the measure of angle LJK. That is the inscribed angle in this picture. Now I've got variables involved. So now I've got to make sure I'm plugging things into the formula in the correct place. Is the angle alone or is the arc alone in the formula?
No.
1/2's over here. That side's not alone. This side's alone. Is that the angle or the arc? Angle. The angle was 9x minus 3 equals 1/2. The arc. The corresponding arc to that inscribed angle is the 16x plus 8. I want to solve this. What do I have to do?
I think we should get rid of
Time
that.
distribute.
Get rid of the 1/2 by distribution because it's being multiplied by it. There are other ways to get rid of that 1/2. But if you choose to do the multiply by 2 over 1, you have to remember to do it to the entire other side of the fraction. And that messes with people. So we just tend to distribute. 9x minus 3 equals 1/2 times 16x. 8x. 1/2 times 8. 4. Now we're solving. Minus 8x plus 3. X equals 7. Is that what we were looking for?
No.
No, what do we need to do?
Plug it in.
9x.
Plug it back into the 9x minus 3, because that's what I was trying to solve for.
That would be 60.
That 63 minus 3 is indeed
60.
60 degrees. Sometimes you might have to plug things back in. Pay attention to what it asks you to solve for. Try out the last one on this page on your own. What is the answer? So you know it as 95 degrees. Sorry, 95 equals 1/2. The corresponding arc. What is the corresponding arc? Yes, because the way that it works is it works with angle goes out, that thing between it is the arc. So in this case, in parentheses, 14 is 24. How does that letter go over there? Says self-corrects. That's it. Yes. Don't get me wrong, you can get out of the decimals, but.
Jacob, do you get this?
No, so I'll have to get out of this situation.
Just said self-corrects.
I'll have to
Double check your
get out of the situation.
thing on your division.
You're still at
Sure.
the point?
Got it.
What? What is he doing?
Wait, tell me the worksheet now or not?
Oh, yeah.
We got two more pages out.
Everything was 95.
I'm failing this test wrong. I'm so failing this test.
Tell your
I don't want your hands to stick out.
You can easily.
I don't wanna hear it, bro. You failed this test before.
Your perm,
I never took it.
Yeah, this is first time doing this.
Why are you in this class?
because in 9th grade, I got COVID and I failed algebra.
So, if I want to write this equation, do I start with the 95 or the 14x plus 22?
I have no idea.
Formula says angle equals 1/2 arc. Which one's the angle?
95.
95 equals 1/2. Its corresponding arc is 14x plus 22. Next, I'm going to distribute the 1/2. I get 7x plus 11. Subtract 11, I get
84.
84 equals 7x. Divide by 2, and x is? Sorry, not a 2, 7. X is 12. What's another way we could have gotten rid of that 1/2?
Times by 2.
Multiply by 2 on both sides. That would have canceled out. You would have gotten 190 equals 14x plus 22. But in the end, you still would have gotten that. Okay. Now when it comes to inscribed angles though, oh, I hit the wrong button. Wrong kind of freeze. When it comes to inscribed angles, it is possible to have a pair of inscribed angles that intercept the same arc. So right here, that angle and that angle both have this shared intercepted arc. And that's a key thing here. Is that arc is shared. That arc has two inscribed angles in which the endpoints of the chords are the exact same 2 points. If two inscribed angles of a circle intercept the same arc, then the angles are congruent. Angle ADE is congruent to angle ACB. That's what you need.
That's it?
That's what that theorem is. Technically, there's a little bit more to it, but the if is hard to write out, hence I just wrote shared. So, find the indicated measure. The first one we want to find is the measure of HJL. That's this angle. I notice that this angle is an inscribed angle. I also notice there's another inscribed angle. Do you notice that both of these inscribed angles have endpoints of H and L?
Yeah.
So does that make them congruent?
That makes them congruent. So what is the measure of HJL?
109.
109.
I'm just here. I don't know.
We'll chat during work time a little bit, Jacob. Okay. Language.
We don't use such profane words.
Okay. So, measure of angle ZXW is next. ZXW. I want that angle. Thoughts on it?
Yeah.
72.
It's the same as this one because these angles have these same endpoints. So, yes, measure of angle ZXW is indeed 72 degrees. It also asks about the measure of arc ZYW. ZYW goes from here to here. Is that the intercepted arc of the angles we were looking at?
Kind of. Yes.
No.
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 Yeah.
Because if we were talking about this angle this is its intercepted arc. An inscribed angle and its intercepted arc make a closed, almost triangular looking thing, but one side's curved.
I got an idea.
Well, you can just solve for that one and then.
Yeah, I was just gonna say that.
But we could solve for that
And
one.
then subtract from 180.
No.
Or 360.
Subtract from 360 because arcs of a circle have to add up to 360. And because this intercepted arc is the only part I didn't want. So, how do I find the measure of that arc?
You times 72 times 2, which is 144, and you subtract that from 360.
Indeed, because they say the measure of the angle equals 1/2 the measure of its intercepted arc, and I know you didn't necessarily go through this full math to get there, but some people need it, so I'm going to write it out. And if you want the measure of the arc, you multiply by 2 then. So yes, the measure of ZW was indeed 144 degrees, as you said. Therefore, to find the measure of ZYW, I take 360 minus that 144.
260.
216, is that what I'm hearing?
Yep.
216 watts?
Oh,
Degrees.
yeah.
Degrees. Angles and arcs are both degrees. Now question C asks us actually to solve for a few different things.
That's too much work. Let's skip it.
Good point, Jason.
Yeah.
Terrible point, Chase. No.
Good idea.
It's a good idea that I give you 50 problems like this and you don't know how to do them?
Yep.
You sure?
No.
Please don't. Let's
Oh.
do
Yeah,
it.
I think it's a good idea. Let's go to B lunch.
We know
and C
everything.
lunch.
Yeah, let's go to B lunch.
No,
And
I
see
think
lunch.
she won.
Both of them.
We should just
No.
like have all the lunches.
A lunch sleepover.
Let's finish the notes. How about that? So we get some work time?
Makes sense you said that, Diego.
We'd like work time today?
Yes, please.
I would like you to have some. Okay, so next, I want to solve for the numbered angles. How many angles am I solving for?
4.
4, because when it says the numbered angles, I'm looking for the angles that don't have a degree symbol. Okay, I can solve them in any order. Why not? Let's go in order. Measure of angle 1. I heard 60 degrees and you'd be 100% right. Why?
Congruent. Inscribed.
Because it's an inscribed angle that has this arc in common. So these two are congruent. Okay, measure of angle 2.
Well, for me, it looks like it will be whatever 60 plus 90 subtracted from. Nope.
Nope.
Okay, never mind. So you couldn't. That's not a 90-degree angle. Never mind.
Correct. We do not know that that is a 90-degree angle. But this is an inscribed angle with this as its corresponding arc.
Oh, so just
So it's 20.
Angle is 1/2 the arc. So yes, it is 20.
I'm done.
And that would also be the
That would also be the
measure.
measure of angle 3 because measure of angle 2 and measure of angle 3 both have the same intercepted arc. Last one I need is angle 4. Is angle 4 an inscribed angle?
Nah.
No. Is it a central angle?
Nah.
No. It's just an angle somewhere inside of a circle. If it is just an angle somewhere inside of a circle, we do not currently know its relationship to arc length. But one of the things you've probably started to figure out by now is when in doubt, what shape tends to pop out in pictures that tends to be helpful?
Where? Triangle.
Triangles. I got a triangle right here. What do you know about the angles inside of a triangle?
They all 100.
Add up to 180. Measure of angle 4 is equal to whatever 180 minus the 60-degree angle and minus the 20-degree angle that is angle 2. Measure of angle 4 is equal to 100 degrees. Last one on this page is looking for the measure of QRT. So, I'm looking for this angle. Now I see a lot of inscribed angles there. Specifically, 2 of them have measurements. Both of those 2 that have measurements. There's its intercepted arc. There's its intercepted arc. If they share an intercepted arc, they are congruent, aka equal. Subtract the 9x. 3x minus 13 equals 2. Add the 13. 3x is 15, therefore x is indeed 5. Is that what it asked you to solve for? No, don't forget to plug it back in. Angle QRT was the 12x minus 13. Twelve times 5 is 60. 60 minus 13 is? 47. 47 degrees. Angles and arcs are degrees. Variables don't technically have units, by the way. Okay. When it comes to working with inscribed angles, there's one other thing we need to focus on, though, and that is the fact that inscribed, as I mentioned earlier, means fitting it inside of another shape as tightly as possible, as big as possible. And therefore, it is possible to put a polygon inside of a circle. By making that polygon as big as possible, all of its vertices must intersect the circle, and it is called an inscribed polygon. Now, furthermore, when you have an inscribed polygon, or a polygon where it's inside and all of its vertices are on the edge of the circle can be described as being circumscribed around it. Now on the next page we start to talk about a couple of more theorems that focus on inscribed polygons. Specifically, inscribed right triangles and inscribed quadrilaterals. Because of the fact that inscribed angles are half the measure of their corresponding arc, if you have a right triangle inscribed within a circle, a right triangle is one that has a right angle, right? What ends up happening is that because of the fact that you've got that right angle there inscribed, its corresponding intercepted arc has to be 180 degrees. And the only way you have a 180 degree arc is if that arc is half the circle. And so the end points of that intercepted arc tend to be on a, that's not a radius, diameter. So a right triangle is inscribed if and only if its hypotenuse is a diameter of a circle. So, triangle ABC is inscribed in circle D if and only if AC is a diameter. Specifically, angle B is the right angle in this case. If angle C was the right angle, then angle B would have been the diameter. So, Notice it says if and only if. That means anytime you see a situation where you have a diameter in an inscribed triangle, that's an indication that that triangle is a right triangle. In this case, the right angle would have been which one? The 5x. And a right angle is how many degrees? 90. If we know that this is a 90-degree angle, 5x is therefore equal to 90. Solve for x, and x is 90 divided by 5? 18. Just a random question. Do y'all know the trick to dividing by 5?
Isn't it like that like finger thing?
Nope. That's multiplying by 9s.
Yeah.
To divide by 5, especially if it ends in 0, you essentially move the decimal place 1 and then double it. By moving the decimal place 1, you're dividing by 10. 90 divided by 10 is really easy math. 9. Multiply 9 by 2? 18. Divide by 10 and double. You don't have to do that. You can always use calculator. But some people find that helpful. Okay. I notice in the next picture I have a diameter. Do you see the diameter? Right here.
That's the hypotenuse.
That better be the hypotenuse, which means which angle has to be the right angle?
X.
X. Therefore, x equals
90.
90. I've got multiple variables in this problem. How do I find y?
Triangle something theorem.
Triangle angle sum theorem, which says angles add up to
180.
180 in a triangle. So I take the 180, I subtract the 90 I know, I subtract the 40.
50.
Y is 50. I see a triangle inscribed. Do you see that one of its sides is a diameter?
Yeah.
That's the diameter. Which means that must be the hypotenuse.
Right.
Which means there's a right angle
It's hidden behind the arrow.
hidden behind the arrow right here. How do I solve for x?
35 equals
What? Just
Nope, those
What?
are not
You
equal.
Just do the,
triangle angle.
Well, if we know the other.
Triangle angle sum theorem. Angles of a triangle add up to
180.
180. So, now I can't necessarily just do 180 minus each of these as easily. I could. The other option is to actually say add them. 35 plus the 90 plus the 2x minus 6 equals 180. And just straight up add up all the angles because they're in a triangle. I combine my like terms. 35 plus 90 minus 6 is a positive 119. Subtract the 119. 2x is equal to 61 indeed. Divide by 2. X is 30.5. Decimals okay?
Yeah.
Yes, you are allowed to have decimals. You're allowed to have negatives as long as it doesn't make angles or segments negative. Okay, final theorem. This is the theorem that tends to get the most mixed up, even though it's really not a terrible one. But people tend to oversimplify these problems. When you have a quadrilateral stuck inside of a circle, what ends up happening is that you end up having two angles across from one another, and actually two pairs of angles, technically, where their intercepted arcs make the full circle. Arcs add up to what? 360. And if I'm going to divide them in half, That means the angles add up to half of 360. 180. Opposite angles of an inscribed quadrilateral are supplementary. A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary, is what the actual theorem states, but it's the same idea. D, E, F, G is inscribed. In circle C, if and only if angle E and angle G, which are across from one another, are supplementary, and angle F and angle D are supplementary. And supplementary means they add up to oftentimes people set the opposite angles equal. Be careful of that. That's not what the theorem says. So, I want to solve for A. A is connected to the 3. According to the theorem, opposite angles are supplementary, so the ones across from one another add up to 180. So 3A plus
65.
across 111 equals 180. Subtract the 111. Get 69. Divide by 3, and A is 23. What's the equation look like to solve for B?
B plus 65 equals 180.
B plus 65 equals 180. Making B 115. Go ahead and try out the last one on your own.
Is this right? What?
Give him a chance to think, please. Please don't throw things in here. I will be coming around, taking a look at what people got here in a second.